Okay, students, last class we will study to the organic chemistry, hydrox derivatives and alcohol lessons, introduction, IUPAC name and then preparations of alcohols. So, we will go today going to how will you the distinction between primary, secondary and tertiary alcohols. Some of the important method, one is called Lucas test, another one is called Victor-Mayer test. I will explain first one, Lucas test. The important Lucas catalyst is anhydrous zinc chloride and concentrated hydrochloric acid. So unhydrated means the water is continuously released and concentrated hydrochloric acid. It is one of the important one more question. What is the Lucas catalyst? So hydrated zinc chloride and dilute hydrochloric acid. So the compound is mingled. We will difficulty one more questions. Very simple. Okay, it is a catalyst of the anhydrous zinc chloride and concentrated hydrochloric acid. First I will take it the tertiary alcohol. You know tertiary alcohol, the functional group substituted carbon is directly involved in 3 alkyl group. That is called the tertiary alcohol. So I will take this compound, will add anhydrous zinc chloride and hydrochloric acid. So the hydrochloric acid is reacted to the tertiary butyl alcohol. So you will get it, one water molecule is going out, one water molecule is going out. So the chlorine is substituted this part. So you will get tertiary butyl chloride. So the alcohol hydroxyl group is levitate. So going on chlorine atom. So you will get a tertiary butyl chloride. Another one. I will take secondary butyl alcohol or secondary alcohol. So secondary alcohol means hydroxyl group present at carbon is directly involved to the 2 alkyl groups. That is the secondary alcohol. The same catalyst we will obtain zinc chloride and hydrochloric acid. So the same water molecules is going out. The chlorine is added. Substitute this part. So you will get isopropyl chloride or 2-chloropropane. 2-chloropropane or isopropyl chloride will get it and leave it water molecule. So what is the, how will you identify tertiary alcohol and secondary alcohol? Very simple. You will add the Lucas catalyst in the tertiary butyl alcohol. You will get the turbidity immediately. The immediate appearance of turbidity. The turbidity is immediately appearance. You will get it. It is a tertiary compound. Suppose the turbidity is slow. So we will get it the secondary alcohol. Then tertiary alcohol. So tertiary alcohol. What is the tertiary alcohol? Tertiary alcohol. Sorry, it is the primary alcohol. Okay, primary alcohol. I will take ethyl alcohol. So I will add the same Lucas test, zinc chloride and hydrochloric acid. So the reaction is not formed. So no reaction at room temperature. The reaction is not possible at room temperature. It is the difference is easily identified to the primary, secondary and tertiary alcohol. So firstly we will take tertiary alcohol, you will add the Lucas catalyst, the derivative form immediately. So you will take the secondary alcohol, you will add the Lucas catalyst, the derivative is formed just slow or 5 to 10 minutes. And you will add the primary alcohol, add the catalyst, Lucas catalyst, you will get the, it is not react, so no reaction. Suppose you will heat, just heated this reaction, you will possible the reaction. So the water molecule is levitate, the chlorine is add, you will get it CH3 single bond CH2 and chlorine. In this reaction only possible at some heating. So it is not react in the room temperature. That's all. Next one, another one method, very important method, Victor-Mayer test. The Victor-Mayer test is easily identify the primary, secondary alcohol. So it is clearly explained to the distinction between primary, secondary and tertiary alcohol. First I will take primary alcohol. So I will take the ethyl alcohol. The functional group present at carbon is directly present in one alkyl group, that is the primary alcohol. So the catalyst of Wicker-Meyer compound, phosphorus and iodine, it is substituted to the iodine groups and silver nitrate and nitrous acid, then potassium hydroxide. It is the catalyst of Wicker-Meyer test. So first I take the primary alcohol, ethyl alcohol, we will add phosphorus and iodine. So the alcohol group is levitate. The one iodine group is substitute to this part. So you will get it ethyl iodide. So then I will add the second one catalyst, silver nitrate. So the iodine and the silver is reacted. It is removing silver iodide. So the nitrate group is substitute this carbon. So I will get it ethyl nitrate. Okay. Then I will add nitrous acid. Third one, nitrous acid. Nitrous acid is the HNO2. I write it HONO. Actually it is hydrogen, single bond oxygen, single bond nitrogen, double bond oxygen. That is the nitrous acid. I will take it. It is react to the ethyl nitrate. So that nitrous acid only reacted, it is the functional group. Already you know the nitrate is the functional group. The functional group present at carbon, this one, this carbon is appear in 2 hydrogen atom. Listen here. This is the ethyl nitrate. The functional group is nitrate compound. The nitrate compound present at carbon, this carbon, that means alpha carbon. The alpha carbon presented is the 2 hydrogen atom only. So these two hydrogen atoms reacted to the oxygen. So you will levitate water molecules H2O. So the NOH is substitute to this carbon. So 2 hydrogen atoms, so you will get it double bond. So suppose you will only one hydrogen atom is involved in the reaction, you will get it a single bond. So 2 hydrogen atom is reacted to this compound, you will get it double bond. So then it is reacted with potassium hydroxide, the same NOK. So okay, then so next reacted to the potassium hydroxide, the hydrogen and OH. So levitate the H2O water, then the potassium is substitute this part, you will get NOK. Okay, this is present in the appearance of red color. This is appearance of red color. So once again repeat, you will take ethyl alcohol, first reacted to the phosphorus and iodine. The iodine is substitute to alcohol group. Then you will add silver nitrate. The silver reacted to the iodine, going out silver iodide. The nitrate is substitute. Then you will add nitrous acid. The nitrous acid only reacted to the alpha carbon hydrogens. Okay. Then you will react to the potassium hydroxide. You will get it red color compound. Okay. Next going to the secondary alcohol. So I will take isopropyl alcohol. So isopropyl alcohol is one of the secondary alcohol. The functional group present at carbon is directly involved in 2 alkyl group. So isopropyl alcohol. Then the same catalyst add one by one. Okay. Then phosphorus and iodine added. The same process. The alcohol group is levitate, the iodine group is substitute, so we will get it isopropyl iodide. Then add second one catalyst, silver nitrate. Though silver iodide is levitate, the nitrate is substitute, so silver iodide is going out. The nitrate compound is substitute. Then you will add a nitrous acid, the same. That is the functional group. It is the functional group. Functional group present at carbon is the alpha carbon. This carbon are present at only one hydrogen. So the one hydrogen, you will take one HO, it is levitate H2O. This position, 2 hydrogen atom are present in this compound carbon. So you will take only one oxygen going out water. As well as this position, only one hydrogen atom present in carbon. So you will take it hydrogen and oxygen is going out H2O. That is the difference. Okay, then the NO group is substitute this carbon, you will get it NO. This position present in double bond. Why? 2 hydrogen atom is leaving out, so you will get it double bond. This position only single bond. Why? The hydrogen, only one hydrogen atom is going out, you will get it single bond. Next you will add another one catalyst, potassium hydroxide. The potassium hydroxide is not reacted. Why? In the position potassium NO hydrogen is present this position. It is not present in hydrogen. So the hydroxyl group is not reacted to the hydrogen. So the reaction is not possible. This is present in blue color. It is the main identifications of primary alcohol and secondary alcohol. Primary alcohol finally get it the red color. Secondary alcohol finally get it the blue color. Okay. Then I will take tertiary alcohol. Or you know, a tertiary alcohol, the functional group present at carbon is directly involved in 3 alkyl group. Okay. The first catalyst phosphorus and iodine. So the hydroxyl is going out, the iodine is substitute. So I will get it tertiary butyl iodine. Next, you will add silver nitrate. The same silver iodide is going out, the nitrate is substitute. So minus silver iodide. Then you will get it tertiary butyl iodide. So the same nitrous acid is added. It is the functional group. The functional group present at carbon is the alpha carbon, and the alpha carbon is not present in hydrogen. We will compare the primary and secondary position. In primary position, the alpha carbon present in 2 hydrogen atom. So one oxygen is going out, what is relieved. In the position secondary alcohol, the functional group present at carbon, that are alpha carbon, only 1 hydrogen atom present. In the position, the hydrogen atom is not present, so the reaction is not possible, so the no reaction. So no reaction, it is not formed to the color in potassium hydroxide. It is the colorless compound. So then, how will you identify primary, secondary, tertiary alcohol in Victor-Meyer test? First, the primary alcohol produce you will add one by one in the Victor-Meyer catalyst. You will get finally red color, that is the primary alcohol. You will add Victor-Meyer catalyst one by one. Finally, you will get it the blue color, that is the secondary alcohol. Colorless, that is the tertiary alcohol. Okay. Okay, students. Then we will going to the physical properties of alcohols. Physical properties of alcohol. So generally, alcohol the boiling point is very low. Lower member alcohols, higher member alcohols, and lower member alcohols is liquid state. Higher member alcohol is in waxy conditions. But the same number of alcohol. For example, you will take ethyl alcohol, CH3, CH2OH. That is the ethyl alcohol. It is the alkyl group. Or the same ethane, CH3, CH3. That is the ethane. It is the same alkyl group. Okay. Both are same member carbon atom. This is the alcohol, this is the alkane. Compare the boiling point. The alcohol is higher than boiling point compared to the alkane. It is very important questions, very simple but important questions. Why? The alcohol is formed to the hydrogen bond. So the hydrogen bond is very, very important. In blood, DNA, RNA, mostly present in hydrogen bonds. So I will take the alcohol ROH, alcohol groups. So the lone pair of electrons, 2 lone pair of electrons are present in oxygen, already you know. So the lone pair electrons is formed to the one bond hydrogen and oxygen. You will get dotted line. The dotted line is mentioned to the hydrogen bond. The same, you will add number of position. Or another one OH, you will get another one hydrogen bond. So the hydrogen bond, you will get it extra strength in the alcohol. So the boiling point increased compared to the same natures of alkyl groups and alkene groups. Okay. Next then, going to the chemical properties. The chemical properties, mostly very important reactions are present in the chemical properties. This class I will choose the SN1 and SN2 types of reactions. So already you know the substitution reaction. What do you mean substitution? Very simple. You will take ROH alcohol. The alcohol is livid. You will add another one X. X means nitrate, chloride, bromide, avoid. You will take any one. One of the compound you will substitute this part. You will get it RX. That is the substitution reaction. One compound is remove it. You will add another one compound or atom or element, that is substitute this part. That is called the substitution. So I will take two types of substitution reaction. First one, SN2 types of reaction. Very simple reaction. It is a general reaction. I will take the ethanol, CH3, CH2OH ethanol. It is one of the primary alcohol. We will add a hydrobromic acid. So the HOH, water is removed, the bromine is substituted. So the hydroxyl group removed, the bromine is substituted, you will get it ethyl bromide. That is one of the substitution reaction. So how is it possible? The reaction is, how is it possible? What is the mechanism followed this reaction? So very simple mechanisms. I will take the ethanol CH3, CH2OH. Everything the oxygens are present in two lone pair of electrons, already you know. I take this lone pair of electrons and I add hydrogen bromide. The one lone pair of electrons, the oxygen is donated to the hydrogen and give up. So the single bond of hydrogen, oxygen is released or donated to the electron, so you will get it positive charge. Then next step, the bromine is relieved Br minus. I will add bromine in next step. The bromine negative ions is attracted to the carbon. So this bond electron is accepted to the oxygen, it is limited water. So the bromine is substituted to the carbon, you will get ethyl bromide. This is the reaction. Okay. Why meanings of SN2? S means substitution. N means nucleophilic. Nucleophilic means electron substitute part. So nucleophilic. What is mean 2? The same type. It is an intermediate position. In the position, oxygen is quickly accepted to the electron. At the same time, accept the electron and leave it. At the same time, the bromine is attacked to the carbon. So both two compound is reacted this position. It is called 2. So that is the substitution bimolecular nucleophilic reaction. Bi means 2. That the substitution bimolecular nucleophilic reaction. Okay. Another one type, SN1 type, substitution unimolecular nucleophilic reaction. SN1 type is single step reaction. So reactant, intermediate compound, product. That is the single step reaction. SN1 is the two steps reaction. This is the first one step, another one is the second one step. I will explain it. I will take tertiary butyl alcohol, the same functional group, carbon, 3 alkyl groups are directly present in this carbon. So it is the tertiary butyl alcohol. We will add the same hydrobromic acid, the same, the pair of electron is donated to the hydrogen and bromine is limited, bromine negative ions. So we will get the intermediate compound. As well as the same, the electron is accepted to the oxygen, it is limited water. So it is limited water, H2O. So the positive charge is give up the carbon, it is the carbonium ion. So carbon release the ions, it is release the compound, it will get is the carbonium ion, it is the positive ions. Then we will add bromine. The bromine is negative, directly attract to the carbon positive ions, you will get it tertiary butyl bromide. The first step, it is the slow step. Why? Only the oxygen is purely attack to the electrons in the compound. So it is very slow. But the second step is the fast step. Why? So it is quickly attacked with the negative ions, quickly attacked to the carbonium ions. So it is the fast step. So you will get it ethyl bromide, tertiary butyl bromide. At the same time, another one possible structures. One more hydrogen is levitate. H plus. In case it is getting the negative ions. So the negative and the positive will add. You will get one of the double bond. It is the olefin compound, isobutylene. Then you will add hydrogen bromide. It is the bromine is attacked to the carbon. The hydrogen is going to the olefin group. So you will get it tertiary butyl bromide. It is another one way. So in the reaction, two-step reaction, only one compound, which in this step, how will you quickly remove it? Bromine is attacked quickly. So only one compound is dependent to this reaction. It is the substitution unimolecular reaction. This reaction, two compound is dependent to the reaction. It is the two compound concentration is dependent to this reaction. It is the SN2 type reaction. So both are substitution reaction, but the shell is differ. Okay.